Good afternoon. I am Abdul Suboor from the Department of Geology, Theogiri College, Chhatrapati Sambhaji Nagar. Today I am going to present my seminar for pre-PhD coursework on the topic of igneous rocks. So what are the igneous rocks? All the rocks that have formed from the hot molten material through the process of cooling and solidification may be defined as the igneous rocks. They were the first formed rocks of the Earth's crust, hence they are also called as primary rocks. So the rocks that are formed from the hot molten material on the cooling and solidification is known as igneous rock. The molten material, the hot molten material occurring naturally below the surface of the earth is called magma, but whenever these molten material come on the surface of the earth it is known as lava. When it is below the surface it is known as magma. When it is spread out on the surface of the earth it is known as lava. Then some characteristic of igneous rocks: they are generally hard, massive and compact with interlocking grains. So here we can see these are the compact and massive hard rock. The entire absence of fossil. In the igneous rocks, we do not find any traces of fossils generally. The absence of bedding planes. So here, this is a sedimentary rock which have sedimentary strata which have the bedding planes, but in igneous rocks, instead of bedding plane, we have the lava flows. So these are the two lava flows. This is the amygdaloidal basalt and another one is overlying strata is compact basalt. And lava flows may show gas cavities and amygdals. So here we can see these cavities. So these are formed due to the form when the lava flow is spread on the earth's surface. The volatile and gaseous matter released from its top. So these structures are formed. The classification of igneous rocks. The classification of igneous rocks based on the mode of occurrence and depth of formation. So on the basis of their depth of formation, there are three types of igneous rocks. First one is plutonic rocks, second one is volcanic, and third one is hyperbasal rocks. So first we will see the plutonic rocks. These rocks, these are the igneous rocks formed at the considerable depth, generally between 7 to 10 kilometer below the surface of the earth. Because of very slow rate of cooling, these types at this depth, the rock resulting from magma are coarse grained. Because these are at a great depth and slow cooling, and uh, the, the lava, the gaseous matter and volatile matter do not escape from these depths, so they form a large crystal size. Then volcanic rock. These are the igneous rocks formed on the surface of the earth by cooling and crystallization of lava erupted from volcanoes. Since the lava cools down at very fast rate, the compared to magma, the grain size of the crystal formed in these rocks are very fine, often microscopic. Uh, when Whenever the cooling rate is fast, the uh, crystal size is very fine, but when the cooling rate is slow, the large crystals are formed. The Deccan Trap of India is spread over more than 5 lakh square kilometer in peninsular India provide the best example of volcanic rocks. The Panjal traps in Kashmir, Himalayas provide another example. The basalts of Columbia Plateau and the Prana Plateau of Brazil are another well-known examples. Then hyperbasal rocks. These igneous rocks are formed at intermediate depth, generally between up to 2 kilometers below the surface of the earth. It exhibit mixed characteristics of volcanic and plutonic rocks. The porphyries of various composition are example of hyperbasal rocks. Mineral composition of igneous rocks. The mineral of igneous rocks are broadly classified into two groups, that is, first one is primary and another one is secondary minerals. So the first primary minerals are the minerals which have developed as a result of crystallization from magma. Primary igneous minerals can also be further grouped into two, that is, essential minerals and accessory minerals. The first one is essential minerals are those which are necessary for the classification, identification, or naming the rock in the which helps in the nomenclature of the rock. The second another one is accessory minerals are present in small amount and therefore not important in any nomenclature. The example, in granite, the quartz and feldspar are the essential minerals, while biotite and hornblende are the accessory minerals. Then the secondary minerals are those which are formed after the consolidation of rocks either by the alteration of primary minerals or by the precipitation of solution. The secondary minerals are those which form in the cavities of igneous rocks by the hydrothermal solutions. These are normally found in the volcanic igneous rocks. The examples are calcite, zeolite, and secondary silica like agate and chalcedony. Then the classification on the basis of the color of igneous rocks. The mineral commonly occurring in the igneous rocks may be broadly classified into felsic and mafic varieties. The felsic is a term derived from the feldspar, feldspathoid, and silica. The mafic is similarly derived from ferromagnesian minerals like biotite, pyroxene, and amphibole. The felsic minerals are light in color with low melting point and having the low specific gravity. For example, the minerals from the silica and feldspar group. The mafic minerals are dark in color, higher specific gravity with higher melting point, and are early crystallized minerals. Their example, the mineral belonging to the pyroxene, amphibole, mica, or olivine groups. The term like leucocratic and melanocratic refers to the light colored and dark colored minerals respectively. The rocks which are pitch dark in color are termed as hypermelanocratic. The mesocratic rocks are intermediate in color. Then the texture of the rocks. The texture of a rock is defined as the intimate mutual relationship between the minerals and the glassy matter in a rock made up of a uniform aggregate. The texture is used to describe the overall appearance of a rock based on the size, shape, and arrangement of interlocking minerals. The texture of an igneous rock is said to be function of its crystallinity, granularity, shape of the crystal, and the mutual relationship of the minerals or the mineral and glass. First we will see the crystallinity. The crystallinity is a ratio of the crystalline and non-crystalline, that is glassy matter in the rock. The rocks made up entirely of minerals are called holocrystalline. The example is granite. The rock containing only glass are called holohaline. The example is obsidian. If the rock is fully uh, made up of glassy material, it is known as holohaline. While the rock, like basalt, may contain both mineral and glass, are called hemicrystalline. The example is rhyolite. Then granularity. Granularity is related to the absolute size of minerals in igneous rocks. Accordingly, rocks are described as phaneric or phanerocrystalline if their minerals can be distinguished separately with the naked eye. The example, coarse grained rock like granite. This may not be possible in fine grained rocks, in which the mineral grain cannot be distinguished by the naked eye. Such rocks are described as aphanetic. The fine-grained rock like basalt. The shape of a mineral is an important criterion for describing and interpreting the texture of the rock. In a hollow crystalline rock, if the mineral grains show well-developed crystal faces, they are termed as eohedral. If only some crystal faces are developed, the grains are termed as subhedral. When no crystal faces are developed by the minerals, the grain is termed as anhedral. Then mutual relationship of the minerals. The mutual relation of the minerals are described by taking into consideration crystallinity, granularity, and shape of the crystal. Based on these parameters, two broad terms are recognized. First one is equigranular and inequigranular texture. First one is equigranular texture. If rock consists of mineral grains of almost equal sizes, it is said to possess an equigranular texture. As this texture is characteristically shown by rock granite, it is also known as granitic texture. The second one is inequigranular texture. If rock consists of mineral grains and other constituents like glass having different sizes, it is said to possess inequigranular or porphyritic texture, in which large crystals called phenocrysts are embedded into matrix of fine grain or glassy groundmass. The porphyritic texture is typically shown by volcanic rock like basalt. Then we will move to the structure of the igneous rocks. The structures of igneous rocks are large-scale features which are dependent on several factors like composition of magma, viscosity of magma, the temperature and pressure at which cooling and consolidation take place, the presence of gases and other volatiles. The igneous structures are commonly classified into three major groups. The first one is megastructure, minor structure, and microstructures. The first one is megastructure. These are usually formed these are usually formed in the flow stage of the magma and include the first one is vesicular and amygdaloidal structure. When the lava heavily charged with the gases and other volatiles are erupted on the surface, the gaseous constituents escapes from the magma as there is a decrease in the pressure. Thus, near the top of the flow, empty cavities of a variable dimensions are formed. The individual openings are known as vesicles and the structure as a whole is known as vesicular structure. If, however, the vesicles thus formed are subsequently filled in with some low temperature secondary minerals such as calcite, zeolite, chalcedony, these infillings are called amygdals and the lava containing amygdals are said to have amygdaloidal structure. The another one is blocky lava. Since the lava of acidic composition due to their higher viscosity do not flow to the greater distance. They after solidification are found to offer a very rough surface. Such lava flows are known as blocky lava. It is also known as R structure. The third one is ropey lava. The lava of basic composition are quite mobile because of their low viscosity and they can flow to the greater distance and after solidification offer a very smooth surface. Such lava flows are known as ropey lava and are also known as Pahoehoe structure. The fourth one is pillow structure. It consists of isolated pillows shaped masses piled one upon another. These are produced by extrusion of lava into beneath ice sheet, underwater logged sediment or in sea waters. The columnar structure, fifth one, as a subsequent of contraction due to cooling, a few sets of vertical joints develop. Such joints bring about the formation of columns which may be square, rectangular, rhombic or hexagonal in outline. The sixth one is platy structure. This is due to the development of different sets of joints which give rise to only plates of the rock masses on striking the rock. Such feature known as platy structure. The sheet structure, the development of one set of well-defined joints sometimes brings about a slicing effect on the massive igneous rock body. If all the such slices are horizontal, the structure is said to be sheet structure. In minor structure, these structures are formed in the fluid stage of the magma, that is in the intrusive rocks, and include the following. The first one is primary foliation, which is sometimes many plutonic rocks are characterized by foliation resulting from the parallel arrangement of platy and ellipsoidal mineral grains. The second one is bonding in rocks. These are also known as layered rocks consisting of alternating bands of different compositions. It may result from lamellar flow, from settling of mineral, from a crystallized magma, or from successive injections. The Schillerian. These are somewhat wavy, streaky, irregular sheet, usually lacking sharp contact with the surrounding igneous rocks. They may be altered inclusions, segregation, or may represent concentration of residual fluid into layered in a rock that had otherwise crystallized. Then the microstructures, the these are these are formed due to the reaction between already solidified crystal and the rest of the magma, and include the following. The first one is reaction rim. When the reaction between an already crystallized mineral and the rest of the magma is incomplete, the corroded crystal are found surrounding by the product of reaction, that is some new minerals. Such zone are known as reaction rim. Second one is myrmekite structure. It is produced by an intergrowth of quartz and plagioclase feldspar, where quartz occur as a bleb or drop in a plagioclase. The third one is graphic structure. It is results from an intergrowth of quartz and orthoclase feldspar. The spherulitic texture, its essential feature is simultaneous crystallization of fibrous with radiating arrangement about a common center. So this was my presentation for the pre-PhD coursework. Thank you.